Hey guys, we're on Unit 8. This is day 1. We're going to talk about solving by factoring. In fact, we just did that in the warm-up for our day. Once we found our factors, we just do our little t-charts where we set each factor equal to 0 and we solve. All right? And what we're going to talk about that those solutions are actually called roots. Okay? Roots of a function are solutions to the equation when it equals 0. Roots are also where the function crosses the x-axis. Okay, known as x-intercepts. Okay, so if we have let's say, a parabola or a quadratic that crosses the x-axis twice, those are roots right there. Those are the solutions you find when you're factoring. There's a couple categories of roots. First one is real roots. These are roots or solutions that actually lie on or can actually be seen on the x-axis, like these two here. Okay. Then there's a subcategory of real roots. They could be rational roots, okay, which are x-intercepts that are nice numbers. Like, for instance, if this crosses at, let's say, -2 and +3, those are rational roots. They are numbers that can be written as a fraction of integers. Okay, so for instance, -2 could be written as a fraction, -2/1. Okay, rational roots can also be numbers like 4/5. That's a fraction of integers. Okay, 1/3. All right, or they could be whole numbers like -5. Okay. That's an integer. They could be 0. All right, and then there's something called a double root. Double root occurs when a function touches or is what they call tangent to the x-axis. The function does not cross the x-axis. In that case, you get something called a double root, and this is a picture of a double root. So the function just comes down, touches the x-axis, and bounces back up. So right here, we would have those two solutions when we were finished factoring and solving. Notice they're the same solution, so there's two of them. All right, but when you graph it, it only looks like it has one root where it touches the x-axis, but this is actually what they call a double root. Then there's something called irrational roots. These are x-intercepts that are not nice numbers or numbers that cannot be written as a fraction of integers. A lot of times they're going to be square roots of numbers like square root of 2 or the square root of 3 or something like that. Okay. And the final category of roots is non-real roots. These are roots or solutions that cannot be seen on the x-axis. The function never crosses or touches the x-axis. They occur when taking a square root of a negative number. So for instance, the square root of -3 is non-real. In fact, when you type that in your calculator, it'll tell you that it's non-real. And this is what the picture looks like. It almost looks like your parabola or your quadratic is what I call floating. All right? So this quadratic here has roots, but they're not real. You can't see them. It's actually what they call imaginary. All right? So let's go ahead and see what we have down here. It says for the following, determine the number of zeros that should be found. Zeros, remember, are the same thing as roots or solutions or x-intercepts. Okay. They want you to find the zeros for the following and then identify the zeros as real, rational, or irrational, or non-real. All right, so let's take a look at the first one. Determine the number of zeros that should be found. So right here, this highest exponent of 3 tells me that there's going to be 3 zeros. In fact, if I come down to this one in number 2, this highest exponent of 4 tells me that this one's going to have 4 zeros. And if I scroll down here to look, the highest exponent of 4 here means that there's going to be 4 zeros or roots. Okay. And this one here with the 8 tells me that it's going to have 8 zeros. That's a lot. Okay. All right, so coming back up now, we're going to go ahead and find the zeros. So in number 1, nice thing is that this is already all on one side. We're going to just replace f of x with 0. Okay, because remember, you can't factor unless you're equal to 0. And now that we are ready to go, we can go ahead and say, how do I factor this? Remember, the first type of factoring you should always check for is greatest common factor. And in here, since all my coefficients are even, I know that there's at least an even number I can pull out of there, like 2. I don't think that there's anything higher that I can pull out, but I can also pull out an x. So I'm going to go ahead and pull out 2x. And I'm going to be left with 5x squared minus 13x minus 6. And don't forget we're equal to 0. Okay. Now what I have inside my parentheses is a hard trinomial. So I'm going to set up my x box. My multiply is going to be my 5x, which is negative 30. And my add will be negative 13. Careful, 3 and 10. Both negatives seem like they would work, but they won't for the multiply. So I'm going to go with negative 15 and 2. Make sure that they work in the multiply and the add before I go ahead, and they do. Before I forget this 2x up here, because he's not going to be used till later, I'm going to just drop him down here. Now I'm going to go ahead and finish factoring my hard trinomial. So I'm going to write my 5x squared. Going to go to my x box and grab the minus 15, put an x on it, grab the plus 2x from the x box, and then minus 6. And then I'm going to go ahead and regroup. And out of the first one, I can pull out a 5x, left with x minus 3. Out of the second one, I'm going to pull out a positive 2, left with x minus 3. And therefore, x minus 3 is going to become my second factor next to the 2x. And 5x plus 2 will be my last one. And don't forget, we're still equal to 0. All right, so there's my factors. Nothing else can be factored. That's completely factored. Okay, but they're asking me to find the 0, so I'm going to keep going. And I'm going to go ahead and do my t-chart between all my factors. This 2x is going to get set equal to 0. X minus 3 will get set equal to 0. And 5x plus 2 will get set equal to 0. Over here, we're going to have to divide by 2 in order to get x equals, and 0 divided by 2 is 0. Over here, if I add 3, x will come out to equal 3. And over here, I would subtract 2, which means my 2 is negative, and then I would divide by 5, so negative 2/5. And there are the 3 zeros. Remember that we said we would get up at the top, and we found them all. Okay. The last thing they want me to do is classify them. Identify the zeros as real, okay, rational or irrational, or non-real. And so I'm going to go ahead and say that 0 is real and rational. 3 is real and rational. Negative 2/5 is real and rational. All right, so I have 3 real and rational roots. Okay. If I were to go ahead and graph this, and I already have, so I'll just give you a little sketch of the picture I saw in my calculator, but it would look something like this. This is the negative 2/5, this is the 0, and this is the positive 3. And so you can see that it has 3 real x-intercepts, or 3 real zeros, okay, solutions or roots. All right, let's take a look at the next one. Number 2. So we are already equal to 0, which is awesome. So we can go ahead and factor. And hopefully you notice this one or recognize this one as a factor by grouping. This is the one where it has 3 groups. So we're going to go ahead and group, and group. Remember, don't rearrange it and don't combine like terms. In the first group, we can pull out a k squared. And left over with a k squared minus 4. Out of the second group, we're going to pull out a positive 8k. And we'll be left with k squared minus 4. Out of the second group, we can pull out a positive 12 and left with k squared minus 4. And don't forget, we're still equal to 0. All right, so all the groups are the same. K squared minus 4 happened 3 times, so we're going to now pull out k squared minus 4 as our first factor. And all the guys on the outside get squished together and become my next factor. All right, but I'm not done factoring because this very first one is what we call a D2PS. And D2PS's get factored into two sets of parentheses. We take the square root of k squared, which is k. D2PS's have one plus sign and one minus sign, and then the square root of 4 is 2. Okay. Over here, we have a nice easy trinomial, so we'll set up our x box. Our multiply is 12, and our add is 8, and the numbers that'll do the job are 6 and 2. Because it's an easy trinomial, we can go right to the factors of k plus 6 and k plus 2. And we are equal to 0. And there's our factors. If they just wanted factors, we would be finished right here. Okay? But they want solutions. So we're going to go ahead and set up our t-charts. And here, guys, we would have k plus 2 equal to 0. K minus 2 equal to 0. K plus 6 equal to 0. Almost wrote an X. And K, oops, at that time I did write an X. Sometimes it's hard to change your habits when you're used to X's and not K's. So we'll go back and switch those back to K's plus 6. And K plus 2 equals 0. All right, if I go back and solve, this one will give me a K equals negative 2. K equals positive 2. K equals negative 6, and K equals negative 2. And those are my solutions. So remember at the top, we said because the highest exponent was 4 that we would have 4 zeros. So we double check that. And now they want us to classify them. So negative 2, what you have to watch out for is that we have 2 of them. So this is going to be real. It's going to be rational. But it's also going to be a double root. Okay, so real, rational, but a double root. And I'll show you guys what that looks like in the picture in a second. So the k equals 2 will be real and rational, and k equals negative 6 will be real and rational. So even though there's 4 zeros, when I show you guys the picture of what the graph looks like, you won't see 4 because of the double root. You'll only see 3. And so it would look something like this. All right, right here is going to be the negative 6 root. Right here is the double root at negative 2. So you're going to notice that the graph comes up, just touches the x-axis and goes back down. And so that's what they call being tangent to the x-axis. And when you're tangent to the x-axis, that's where that double root occurs. Okay, and then this one over here is the k equals 2, 1. Okay, so just so you guys can see the picture and connect the algebra to the graph. All right, let's go ahead and scroll down and let's take a look at number 3 and 4. So in number 3, we have a problem. We're not equal to 0, so we cannot factor until that happens, and we never want our highest exponent to be a negative. So we're going to keep the 4x to the 4th where it is, and we're going to go ahead and bring the 64 over. So we're going to have 4x to the 4th minus 64 equals 0. First type of factoring we should always check for is greatest common factor, and there is one. We pull out a 4. Left over would be x to the 4th minus 16 equal to 0. Okay, x to the 4th minus 16 is a D2PS. So we're going to bring down the 4, and then we'll do the D2PS in here. The square root of x to the 4th is actually x squared. Remember, D2PSs have one plus sign, one minus sign, and then the square root of 16 is 4. And don't forget, we're still equal to 0. Okay, we actually have another D2PS. Okay, so we're going to bring down the 4. This is not a D2PS because D stands for difference, and the difference means subtraction. This is a plus, so this is a sum of perfect squares, and we don't factor those. We don't have a way of pulling those apart. Okay, but this one is a D2PS. So we'll take the square root of x squared, which is x. One has a plus, one has a minus, and then the square root of 4 is 2. And don't forget, we're equal to 0. All right, I don't think I can factor anymore, so now I'm going to go ahead and say my factoring's finished, and I'll set up my t-charts. Here, 4 equals 0, and there's no value of x to solve, and so we didn't get 0 solutions from there. Okay, so that just kind of goes away. Here, we're going to have x squared plus 4 equal to 0. Here, x plus 2 equals 0. And here, x minus 2 equals 0. And I'm going to solve these ones first because these ones are normal to us. So x would equal 2. Here, x would equal negative 2. Remember, nothing happens here. Okay. Over here, what we would have to do is we'd have to subtract the 4 to get this. And then to get rid of the square, we would have to square root. And so we would end up with x equaling, and remember when you square root both sides, it's an even root, that there's two answers. It would be positive and negative square root of 4. Well, square root of negative 4. Later on in the next unit, we're going to simplify these more. But we're not going to work on that skill in this unit just yet. All right. All we need to do is recognize that this is a non-real root because we're taking a square root of a negative number. If you remember up in the text box at the top, that was one of the last things we talked about. So this is a non-real root. Okay. In fact, there are 2 of them here. So there are 2 non-real roots. Okay. If I move over, this is real and rational, and this is also real and rational. Okay, so remember that we said up at the top we'd have 4 zeros, so we have 2 here, a third one here, and then the fourth one here. So we were correct. All right, we'll go box those up. Those are our 4 zeros that we said we would have up here. And let me just show you a little sketch about what this one would look like. Okay. If you were to graph this original equation here, once we got equal to 0, it would look something like this. Okay. Here would be the negative 2. Here would be the positive 2. And you're not going to go ahead and see those non-real ones cross the x-axis. Okay. You only see the real ones on the x-axis. And that's why you're not going to see these 2 right here. Okay. All right, last one. What we have to recognize is that we're not equal to 0 yet, and so we're going to have to go ahead, keep our highest exponent term positive, so we're going to keep that where it is, but we're going to go ahead and subtract the 13x to the 4th on over, and then we're going to add the 36 on over so that everything's on one side, zero's on the other. Greatest common factoring should happen first, but there is no greatest common factor. This is an easy trinomial, but this is what I call an easy trinomial with a twist, if you remember back from the beginning of the year. And the twist right here is the 8. All right, so I just have to remember that when I'm done factoring, or finding my numbers, I should say, what the twist is. So our multiply is still going to be 36, and our add is still going to be negative 13. And the numbers that are going to do the job, I believe, are negative 9 and negative 4. If I multiply them, I get the positive 36, and when I add them, I get my negative 13. Okay, so here's the twist. It's still easy, so you can go right to your factors. However, it's not going to be an x, it's going to be an x to the 4th in both of them. All right, and then minus 9 and minus 4, and then equals 0. Problem with those factors is that they're D2PSs and that they can go again. And so I'm going to go ahead and split this one up. I'm going to take the square root of x to the 4th, which is x squared. One a positive, one a negative, and square root of 9 is 3. And neither one of those can go again. 3 is not a perfect square, so neither one is a D2PS. Okay? However, this x to the 4th minus 4 is a D2PS, so now we'll go ahead and factor that one. Square root of x to the 4th, again, is x squared. One with a positive, one with a negative, and then the square root of 4 is 2. And neither one of those is a D2PS because 2 is not a perfect square. Okay, and so I believe I have my 4 factors. None of them can be factored again, so we're ready to go ahead and do our t-chart. And here we would have x squared plus 3 equal to 0. Here, x squared minus 3 equal to 0. Here, x squared plus 2 equal to 0. And here, x squared minus 2 equal to 0. On this one, we're going to have to go ahead and subtract 3. So we would get x squared equals negative 3. And then we would have to go ahead and square root and square root. And so that would give us x equals, and we have to remember the plus minus anytime we even root both sides. And we're going to leave this as the square root of negative 3. And again, next chapter, we'll learn how to simplify that a little bit. Okay. Here, we're going to go ahead and add our 3. So we'll have x squared equal positive 3. And then we'll square root both. That'll get rid of the squared. So we have x equals. We even rooted both sides. So we have a positive and negative, and then our square root of 3. Here, we're going to go ahead and subtract the 2. So we'll have x squared equals negative 2. And we'll square root both sides. So that just gives me x equals. Because I even rooted both sides, there's my positive and negative, and then the square root of negative 2. And again, next chapter, we'll learn how to simplify that. All right, last one. We'll add 2, so x squared will equal positive 2. Square root both sides to get rid of the square, so we have x equals. We even rooted both sides, so positive and negative, and then our square root of 2. And there are what looks like 4 answers, but because each one has a positive and negative, so there's 2 answers here, 2 here, 2 here, and 2 here, and 2 times 4 is 8, and that is the 8 zeros we said we were going to have in the beginning. All right, they want us to classify these, so because this is a negative, this is going to be 2 non-real roots. Okay. This doesn't have a negative underneath the square root, so these are going to actually be real, but square root of 3 is not a nice number, and so these are going to be 2 irrational roots. Okay, this one over here does have the negative underneath, so we're going to go back to being 2 non-real roots. And here this goes back to not having a negative, and the square root of 2 is a not nice number, what I say, which is irrational. So these would be 2 irrational roots. Okay, so what's going to happen is that you won't see these ones, and you won't see these ones. Okay, but you should see the 2 irrational roots here and the 2 irrational roots here. So you'll see our graph, once I show you what the picture would look like, you should see it cross the x-axis 4 times. So when I put it in my calculator, okay, it's going to look something like this. All right, so here will be negative square root of 3. This here would be negative square root of 2. Here would be positive square root of 2, and this one would be the positive square root of 3. All right, so you can see all 4 irrational roots, okay? But you won't see the non-real ones because they don't really cross the x-axis. All right, I will see you guys on the back side of notes.